All right, this is Mr. Wyrick. I'm here to go over these notes with you just real quick. We have y is equal to a times b to the x minus c plus d. These are the same letters that we've had before, the same kind of changes to the graph. When the b is positive, then it's going to be a growth factor. That means your graph is going to be exponential up in this direction, going off to the right. When the b value is negative, or not negative, sorry. Okay, never mind this, not positive. When the b is greater than 1, it's going to be a growth factor. If we're multiplying by 2 over and over again, if we're multiplying by 3, 4, 5, or even like 1.06, anything that's bigger than 1, it's going to be a growth factor. When the b value is between 0 and 1, it's going to be a decay factor. So we're multiplying by 0.5, we're multiplying by 0.99, whatever, it's going to come down and go like this. So you should never have a negative b value. A negative b value will create a phantom graph. You can try to make one sometime. You can get a table of values from it, but it's not going to work. So on this first one, growth or decay, my b value is 0.12. This will be decay. On this one, I have a 0.2 out front, but that's my a value. My b value is 5. This is going to be growth. And then on this one, we've got 16 times 1/2 to the x. That 1/2 is between 0 and 1. This is going to be a decay factor. The a value, whenever you get word problems for this, that a value is going to be your starting value. So if you look up here, if we start off with $5,000, if we start off with 60 bacteria, if we start off with a population of 1 million, whatever it is, that a value, that's that starting value there. The c value is your left and right shift. It does the opposite of what you would expect, and it's hard to nail down a place. The only point that exists consistently on most of these graphs when you have like the regular version of it is like 0, 1, because most things to the 0 power make 1. So that c value, when it shifts it left and right, it's going to make this be like if we have 2 to the x plus 3, that's going to take that 0, 1 and move it 3 places to the left. It's very difficult to determine left and right shift from a graph, but if you do have the equation, you can say that this is going to be a left and right shift. And then the d value is your up and down, your vertical shift. It's going to set your asymptote. Every single one of these is going to have an asymptote. It's a line that you can get closer and closer to, and you'll never touch it. So if we have 2 to the x power plus 1, then a horizontal line at 1 is going to be what we never ever touch. Everything is shifted up 1, and the graph goes like this. If we have 0.5 to the x power plus 3, then up here at 1, 2, 3, we are never ever going to touch that line, and it'll come down exponential decay. It'll get closer and closer to it. It'll never touch it. Hopefully this gets you along the way. You'll be able to use your calculator to kind of graph these, and I'll put this video along with a picture of this in the classroom.